Let's take a look at this problem. It says complete the table to determine P for the given values of the final balance of 200,000. And R is 3% and it's compounded continuously. Now compounded continuously tells us for this problem we're going to use a PERT formula. And we want to find P. So I'm going to go ahead and divide both sides by e to the RT. So A divided by e to the RT is equal to PE to the RT divided by e to the RT. The reason I do that is because the e to the RT's will cancel then. And I got P is equal to A over e to the RT. So this will be a little easier to work with for this problem. Let's see what they give us. Final balance of 200,000. 200,000. Rate is 3%. So we're going to have e to the 0.03. T is what changes. So that's going to be our variable. So I'll put an X there. And that's going to equal to P. Let's go put this in our calculator. So press my Y equals, press clear. I do 200,000 divided by E. So I do second ln natural log. It puts a E, puts a caret, puts a beginning parentheses. So now I'll put it in 0.03x. And I'll put a closing parentheses, though you don't have to have it. Now I want to make sure my table setup is correct. So I do second window. And independent should be set to ask. If it isn't, down arrow to that line. Right arrow, put your flashing cursor on ask, and press enter one time. Now I'll do second graph to go to table. I'll clean out this old data. There we go. Okay, what are we looking for? T is equal to 1. We've got T is equal to 10. T is equal to 25. T is equal to 50. T is equal to 100 years. And T is equal to 500 years. Okay, so let's go to our calculator now. Put 1 in, 10, 25, 50, 100, and 500. And then we'll press our right arrow key, and I'm going to up arrow. So I get to there. I want to be in a Y column to see all the decimal places. So our first one here is 194,089.11. So if you left it in 1 year at compounded continuously at 3%, you'd have to have this much put in. 10. Let me down arrow to 10. 148,000. 163.64. So if you leave it in 10 years, this is the amount you'd have to start with. And down arrow to 25. And I got 94,473.31. Let me down arrow to 50. And you'd have to have 44,626.03 into the bank. And let me down arrow to 100. Left in 100 years, you'd have to start with 9,957 and 41 cents. And down arrow here, and it says we'd have to start with 6 cents if you were able to leave it in there for 500 years. Of course, we know that isn't feasible, but the exponential growth just really interests me, that you put 6 cents in, and at the end of 500 years, you'd have $200,000.